Welcome to BioIT World's Trends from the Trenches podcast, your insider's look at the science, technology, and executive trends driving the life sciences. I'm Allison Proffitt, editor of BioIT World, and this episode is hosted by Stan Gloss, founder of BioTeam, a life sciences IT consulting company at the intersection of science, data, and technology. Today, Stan talks with George Church about neurodiversity, both from a personal standpoint and how a neurodiverse team brings richness to a lab or work environment. Let's listen in.
So, George, thank you so much for joining me on my podcast today. I've actually had this date circled for a while because it's not often that growing up with dyslexia, you find somebody that you've been working with and have known for as many years as we've known each other, and then come to find out they also have dyslexia. So what I'd like to talk about today is really dyslexic thinking and science and how those two kind of combine. Recently, Richard Branson worked with LinkedIn to make dyslexic thinking now a skill that you can put in your LinkedIn profile. So it's really one of the first times that people actually spoke about the advantage of having dyslexia. So thank you so much for joining me. Maybe we can start off just talking about you and some of your dyslexic journey. And when did you first realize that you had dyslexia?
Yeah, I think that, I grew up in a fairly, in an environment where schools, the schools in Florida, the part of Florida I was in, weren't really of the caliber that I later became accustomed to. My parents respected education, but they couldn't find a school for me until I was 13. And labels like dyslexia were not very common. My mother eventually got a PhD in psychology, but that was when I was 18. So I probably didn't learn as a label until I was in my teens. But I was painfully aware of I couldn't read very well from, I guess, the moment that people started reading. I would compensate in various ways throughout my life. And I think that took some of the sting out of it. I would just figure out real strange workarounds. Like, I was pretty good at pattern recognition. So I would remember a couple of key words so I could impress people that I could recognize, big words and things like that. But it wasn't, I mostly initially, so I guess I would have to say, in first grade, they were just like, if you just knew a couple of words, you were in good shape. But by third grade, I was mostly reading by looking at the pictures. So if the class would get a book that didn't have any pictures in it, I would try to get, or I think my family would arrange for me to get a book that was same material with pictures in it. And I had gigantic collections of like the Time Life series. It was 25 books on nature and 25 books on science, just full of beautiful photographs. I still have both of those collections. And I would more or less memorize the photographs, but I'd have to kind of piece together what the story was.
Yeah, that's so common with dyslexia. I found that with myself, if I pick up on a few words in the sentence, then I kind of extrapolate the meaning from that. Yeah. And I think Thomas Edison was also one who very much was a visual learner and learned mostly by looking at the pictures and mechanical drawings of things. And third grade is the magic grade. That's traditionally where people switch over from learning to read to reading to learn. And that transition just doesn't happen. And it's usually the third grade. For me, that was when I was diagnosed, was in the third grade. But I was lucky that the founder of the Landmark School was a researcher at Harvard University at that time. And he diagnosed me as having dyslexia, but it really didn't matter because at that time, nobody knew what the word was anyway. So sometimes you were just labeled as lazy and stupid at that time. And you just had to learn to live with that. So how did you do academically through grade school and high school? Did you do okay?
Yeah, I did okay. I think, again, it calls these compensating tricks. I don't think I was called lazy or stupid, although partly because I was pretty good at math, which I could do without a lot of reading. And yeah, and I could just remember photograph. I could just remember a lot of stuff. I could remember whatever they said. So basically I would fill in the blanks, like you said. So but I did okay in school, except I was constantly being advised to take outside reading classes. So can't remember all of the years, but one that stands out in my mind is in 8th grade. I took a night school class, and I had never realized that there was such a thing as a night school class. And almost all the other students in the class were working class people that had worked a full day at their job and then added on to their workload taking this night class. And I thought, wow, people take night classes without being told to. I mean, I was basically told to take this class. And it was a classroom where they were teaching speed reading and remedial reading in the same class. And I would get bored with the remedial reading, and I would kind of like to see if I could do the speed reading. And the weird thing was I could actually do like their fastest. They had like a camera that would project onto these like almost stroboscopic words and I was pretty good at that. It was a kind of a esoteric skill, but I could really pick up the words that were flashing. But I was something had to do with this whole page full of words, just like a single word up on the screen. I could kind of get it. Anyway, so I never became a speed reader, that's for sure. But I did. I think my brain just kept rewiring. I think a lot of people's brains rewire over time. Mm-hmm. I mean, for example, I was amazed watching my mother-in-law who got a stroke. She couldn't walk or talk. And now she's just like all the rest of us, just a couple of years later. So your brain has amazing plasticity. And I think that's my brain just, I wouldn't classify myself as a dyslexic today. But there are definitely remnants, but it's not at all like what it was when I was growing up.
Yeah, well, we were all put into very different situations. Now you're optimized to the type of things that you're really good at, and you're capable of choosing to only do the things that you're really good at.
Right.
So, your background is in genetics and evolution. I'm curious to get your thoughts on either genetic wise or evolutionary wise. How does dyslexia fit in? Because it seems like it's a trait that is in my family and keeps moving through the family. So there has to be some genetic component, but it also has to be a trait that is needed, or else it would have gone extinct.
Well, there are quite a few traits that don't go extinct that almost certainly are not needed. So, for example, there's a small number of traits that are lethal in each generation. So they're not inherited; they're created by de novo mutation, like Rett syndrome. But Down syndrome. These are things where usually the kids don't make it to leave behind progeny. But that said, there are plenty of things that seem disadvantageous that might have been advantageous to our ancestors, and dyslexia is a prime candidate for that because there was almost no need for reading up until the illuminated manuscript in the printing press. So it is a kind of a human construct. a technology that left certain subset of people in the dust because they couldn't adapt to the technology. But it might have had and have today advantages because your brain's not working on one thing, it's working on another, and you get hypertrophied at whatever you are working on. So you develop a skill set that's different from everybody else. So, for example, if you're blind, your auditory system gets better, and vice versa. If you're deaf, then you can appreciate without distractions. You're not distracted by conversations and things like that. So that would be my view of the evolution. And if you take that evolution to modern society, to some extent, there are rewards for people. It's not just dyslexic thinking; it's thinking in any way differently. It's like the Apple ads, think differently. Mm-hmm. If you think differently on any axis, if you're ostracized for any reason, then that means that you become more self-reliant, more of a self-starter, sometimes with a little bit of something to prove, but definitely thinking differently, which means that when everybody in the middle of the bell curve is stuck on a problem, you're going to give a new solution, not necessarily because of the skill, but because you're different. So in other words, it could be that a high-functioning autistic or a dyslexic or OCD could all solve this problem that everybody else can't solve, but not because they share some amazing superpower, but simply because they've had to learn how to think separately from everybody else.
Yeah, definitely. I mean, certainly when as an entrepreneur, you started many companies, and I've certainly founded my own company. Entrepreneurs are always presented with incomplete information. You never know everything about a marketplace, and and science, I'm sure, is also quite incomplete. So this skill that we had to kind of find meaning amongst incomplete information now actually becomes advantageous in certain situations.
Yeah, I agree. I think one of the greatest skill sets that I look for in people I'm hiring or people I'm collaborating with or so forth is the ability to deal with ambiguity and to deal with contradictions. People that are like that have to have things according to dogma or according to the way they were brought up, or they become quite brittle and frustrated when things deviate. But people that are really capable of filling in the blanks and sorting out the contradictions or just living with them I think have some terrific survival tools that can benefit everybody by their presence.
Yeah, and I think some of what we get challenged by is that when you talk about dogmas, the dogma of testing and being able to do too well on tests as an indication of it somehow intelligence. And having analytical intelligence is one thing, but then there's creative intelligence and practical intelligence. So intelligence comes in many different flavors and can come in at different ways in a situation in your career or science and all of that.
Yeah, I agree. I think that standardized tests are sort of a predictor of a certain kind of success. Being in the middle of the bell curve means that you fit in the furniture and the houses that are built, and so you succeed in some financial way, maybe. But many of the people that we talk about that were extraordinarily successful in changing our society in a beneficial way were not particularly good at financial. And there certainly are plenty of people who think out of the box who have been very successful in finances, especially recently. A lot of geeks and other neuroatypicals have become billionaires. But I think Einstein and Curie and Tesla, and the list goes on of people that were not particularly wealthy at the end of their life, but boy, they sure changed our the wealth of all of us in a positive way.
So when you look at dyslexia, some people can look at it as a curse. Some people can look at it as a advantage. What do you see as the advantages that you've had as the way you think towards the kind of work that you do?
Yeah, well, I mentioned just being different on any axis is an advantage, but let's talk about the advantages of being specifically on the dyslexic axis. I don't know for sure. This is complete speculation and introspection, but I felt that because my brain wasn't getting wired up to really get good at reading the words in nice straight lines and nice block paragraphs, I tended to look at images, especially 2 and 3 dimensional thinking, that geometry and pattern recognition. I just had more time to do that. I had more aptitude. It became a positive feedback loop where I would say, "Oh, yeah, that's fun. That's fun thinking about what fits inside of what, how to take a 2-dimensional picture and figure out what's the 3 dimensions behind it." And so one of the first bits of science that I did was X-ray crystallography, which was all about spatial symmetries and solving 3-dimensional structures and things like that. And that just totally resonated with me as a teenager, when I started publishing in crystallography. It just said, this is so right. And then many of the things I've done since then have involved imaging. We do super resolution microscopy and fluorescent in situ sequencing, which is a kind of all the next gen sequencing is imaging basically. So I think that's one thing is the shifting from sort of the lexical, the verbal, but in a written sense, thinking versus the imaging and spatial thinking.
So when you look at DNA, do you see it in 3 dimension? I mean, how do you, what do you see when you look at strands of because you look at a lot of DNA?
Yeah, I have. Well, so when I look at a 3-dimensional object like DNA in 3D, I think you're talking about when you see G's, A's, and T's on the page. But when I see a DNA molecule, first of all, I can immediately tell whether it's left or right-handed. I mean, it's just like if it's the wrong handedness, not the natural handedness, it's just like instant. But if I look at 1-dimensional or 2-dimensional objects, if I've been exposed to the 3-dimensional version of it, then it folds up in my head, and I see that kind of thing. If I know, it's much easier to know how parts go together. So, whether it's mechanical engineering or molecular engineering, you have these 3-dimensional objects that have to fit together. Now, we've got terrific software that does this, but it helps if you got an intuitive feel for it. And that's part of the reasons that my lab does a lot of 3D printing, both 3D printing of DNA, of molecular cells, and of course models. It helps us think about it the way that a mechanic thinks about your car. It's like if you've just learned about pistons by reading text on a page, it's a very different exercise than having handled the 3-dimensional objects and put them together like a 3-dimensional jigsaw puzzle.
Right. So you also think very much outside the box, George. Everybody knows that. But a couple of things that I thought were outside of the box were, kind of bringing back a mammoth. That's a little bit outside the box thinking. And then there was a concept that you shared with me a few years ago about using DNA as a way to store data. I mean, tell me about how you come up and use your imagination for these kinds of ideas. Is that part of this?
Yeah, I mean, to some extent, I wouldn't have an answer for you if that question hadn't been asked before, and I try to answer people's questions. So I think about it in between interviews and stuff. And I think that part of the source of ideas, one source is I'm narcoleptic, and so when I typically fall asleep when I'm thinking about something hard. And I like falling asleep, and I like waking up sometimes a few seconds later, sometimes a few minutes later. But whenever I do, if I fell asleep on the hard problem, I very often have a solution. And that whole process is, of course, almost guaranteed to be out of the box. But now that has nothing to do with dyslexia. That has to do with other parts of my brain that are screwed up relative to the middle of the bell curve.
Right.
But I have no regrets for either the narcolepsy or the dyslexia. Another source of the out of the box idea is just simply not rejecting ideas. Again, I think being neuroatypical on any axis causes you to be less judgmental. Let's think this isn't normal is a very common. If this were such a good idea, somebody would have done it already. Well, that's almost a guaranteed algorithm for rejecting everything that's good in the future. Is there are people that write books, that I made the last discovery in this field. There's no more discoveries to be made. Or they come into a field and they haven't even made a discovery themselves. They just say, this field of physics or biology is done. And it's very defeatist. And so what I have a tendency to do is instead, I guess partly it's the championing the underdog, is I think of ideas as if they have faces and souls, and you don't throw them in the trash. You put them up on the wall as something that's a challenge, as something that is in the future, maybe. And you don't have to follow this one bad idea as an obsession, like Captain Ahab and his whale. You can instead just have a bunch of them on your wall, and each and every day you collide a few of them together with some new thing that you just read, you just were exposed to. Let's not say read in the world, and you're just like constantly colliding these things like a super collider. So I think that's where these things come from. The you gave a couple of examples.
Yeah. So it's interesting because when you look for innovation, I've recently was taking a course in design thinking. And one of the places where they tell you to do observations are observations at the extremes of things. Don't look at the middle of the bell curve. Look at the absolute, things that are 3 and 4 standard deviations from mean.
Absolutely.
And because you're going to find more interesting innovations at the edge than you are in the middle. So maybe I'd like to talk about the Church Lab. So you're the leader of the Church Lab at Harvard, and you have a whole lot of people and lots of people who come through your lab. Is being neuroatypical something that or having neurodiversity in your lab, is that something that's important to you? And why?
Yeah. So, I think that we've kind of gone from a world where we discriminated against all sorts of people to a world where we still discriminate against all the people we used to discriminate against. But as we at least attempt to reduce discrimination against, say, wheelchairs, against people who have different ancestries, different religions, gender preferences. There's a residual, which is we still are highly biased against neuroatypicals. So when somebody says, I want to have a diverse classroom, what they really mean is that people have different skin colors and dress differently, right? Might wear a scarf around their head. That's not diversity, right? In a classroom sense, diversity is willingness to question authority, maybe falling asleep during class, maybe not being able to sit still. But that's inconvenient diversity, right?
Right.
Questioning authority, falling asleep, and wiggling is very inconvenient to the teacher, and they would far prefer to have everybody line up in nice little rows and have a diversity of ancestry. So I'm interested, certainly interested in ancestral diversity, but also interested in overcoming the inconvenience of having people that are a little bit out on the bell curve. Now, of course, if you go far enough out on the bell curve, you end up with people that really have to be hospitalized or institutionalized, and so there is a limit. And there are even people that don't have to be institutionalized that are still probably outside the boundaries, like let's say an extreme sociopath, homicidal sociopath is probably not the ideal thing
Especially
to
in your
have
lab, right?
in the work environment. But back to your comment about just before this question about how you're interested in things that are 3 standard deviations out or more. When I teach my classes, talking about creating the culture of the lab, I say embrace your outliers. When you have a scatter plot and everything's all along a nice diagonal and you got something that's off, a lot of people, their tendency is to say, "Oh, I must have messed up that day. Maybe it was an experimental error or some statistical fluke." And worst thing they do is they'll erase it and just say, "Well, we don't need to show that in the article. We need to show the good stuff." And I say, no, that's interesting. That either means that there's some flaw in your methodology that you better find out what it is, because if that flaw happens at a critical moment, like in a system that somebody's life depends on, it's better to discover it while you're still in discovery mode in the lab. Or it could be a real discovery, not of a flaw in your methods that could be fatal someday, but a new phenomenon, a new phenomenon in physics, chemistry, biology. You don't know what it is, but you've got the gift of the outlier. So, and the same thing applies in the workplace. Is you don't want to necessarily train everybody in your lab to be as close to the ideal citizen as possible. You just want them to be comfortable enough that they can deal with their diversity. And so they don't have to be completely comfortable and completely adapted and completely the same, but maybe just enough, maybe so they can turn their superpower on when it's needed, but off when it's one of those inconvenient moments.
Do you think people when you're interviewing people for your lab, feel comfortable disclosing that they may have a neurodiversity, or can you tell when you're interviewing them? I mean, is there something you look for in terms of making sure that your lab has a diversity across the whole lab?
Yeah, well, I mean, I think there's a lot of self-selection. I mean, they can see from, across the globe, just looking at what the sort of things we do, if they're really into status quo, they're not going to even apply. If they want to, get a very mainstream set of publications, well, I shouldn't say that. We do get some mainstream publications, but it's because those mainstream publications do respect outliers. But anyway, if they really like the status quo and they want to be an ordinary researcher, then they just don't apply. So that's one filter that I don't even have to think about. It is true in the first 2 minutes of an interview, there's a lot of things you pick up on. And then a third thing is, I think it's hard to be rigorous about this, but I think that some people are willing to tell me things that they might not normally say in an interview. Maybe I make it seem like the stakes aren't so high, which is certainly the way I behave after they join. So, for example, there was one candidate that applied to my lab, and he had pretty severe diabetes that he normally didn't disclose, but he did during my my interview, and then later he joined a different laboratory, but in our same building, and then he had a diabetic episode where he was completely out of it, and nobody knew what was going on. Nobody around him knew what was going on, and so the departmental secretary knew he had interviewed with me and asked me, and I said, "Yeah, he's got diabetes," and they were misdiagnosing him as having epilepsy and who knows what, and so then that, apparently he had not told anybody else either during the interview or afterwards.
Right.
So that's an anecdote. It doesn't mean that, but I think the point is you need to create a safe enough conversation so that people don't think you're going to reject them just because they have neurodiversity or diabetes or what have you.
So, George, maybe my last question for you is probably what advice we would give young scientists with dyslexia or any other, types of neurodiversity. What could you do to help them? What did you learn, and what advice could you give them if they were going to become a scientist and had dreams of becoming a scientist like you?
Well, first, so there's some things that are available now that were not available when you and I were growing up. In particular, audible books on tape, or not, I guess that's an anachronism, but audible books. There was a movement to do this specifically for people who had trouble reading, either blind or dyslexic. But now it's mainstream. Everybody who's has a long commute or likes to listen while they're doing chores. Certainly, my wife and I mostly read our books via Audible. So that's one thing that you can exploit. Also embrace yourself as an outlier and use it as an opportunity to ask what you can do that's a little bit different, maybe a little bit better in a narrow way. And I think this applies to all sorts of neurodiversity, as we've said, the kind of theme of this conversation. It's not just dyslexia.
Right. Well, George, thank you so much for sitting down with me and chatting about this. I really appreciated all of our years of working together and all the help and advice that you've given to me. So thank you so much, and we'll talk soon.
Yeah, thank you, Stan. I mean, it is interesting how long we didn't know we were both dyslexic, partly because it's not something that we tattoo on our forehead for the most part. Narcolepsy is a little harder to hide, but
that's one I won't. I can tell you I don't join you on that journey right there, but I'm sure if I could wake up from having a narcoleptic episode and have the answers to things, I might want to give that a whirl once in a while.
Yeah. So anyway, it's been a great pleasure talking with you, Stan, on this.
Thank you so much, George.
Yeah. Take care.
If you enjoyed this conversation, we'd love for you to leave us a review and subscribe wherever you get your podcasts. Thank you for joining us. To be part of more conversations like this, join us in Berlin, October 18th and 19th for BioIT World Europe. Save an additional 10% off your registration with the code PODCAST. For more information, visit www.bio-itworldeurope.com.